Hello friends, I welcome you in lecture number 10 on complex numbers. In this lecture we are going to discuss this question which was asked in GTU 2019 examination. So first we understand what is given question. State De Moivre's formula and hence evaluate 1 plus I root 3 to the power 100 plus 1 minus I root 3 to the power 100. So first we have to write what is De Moivre's formula, and using De Moivre's formula we will simplify this expression. So we have discussed already De Moivre's formula in earlier lectures. So we simply write the statement of De Moivre's formula. So as we know, De Moivre's formula is for polar form of the complex number, and it is nothing but power of cos theta plus I sin theta. If we have some power of this cos theta plus I sin theta, then this can be written as cos n theta plus I sin n theta. So we are multiplying this power with this angle. Here n is any integer, n belongs to z, or you can consider n belongs to q also. N is rational number, so it is also allowed. So we have this De Moivre's formula, cos theta plus I sin theta raised to n equal to cos n theta plus I sin n theta. So you can write n belongs to z or n belongs to q also. So n belongs to q is in general, so q includes all the integers also. So this is the statement of De Moivre's formula, and using this De Moivre's formula we try to simplify this expression. So here we have two complex numbers, 1 plus I root 3 and 1 minus I root 3, and this is conjugate of 1 plus I root 3. Now to use De Moivre's formula we have to convert these two complex numbers into polar form. So first we consider z equal to 1 plus I root 3. So first we find out polar form of this complex number z. So as we know, we have to find out absolute value of z and argument of z. Absolute value of z is denoted by small r, and it is defined as square of real part, here real part is 1, and square of imaginary part, which is root 3. So this is going to be 1 plus 3, that is square root of 4, and which is equal to 2. Now to find out argument of z, we compare this with x plus iy. Suppose this is x plus iy, then we have x equal to 1, y equal to root 3, and if theta is the argument of z, we know that tan theta is nothing but y divided by x. So we have root 3 divided by 1, that is root 3. So therefore tan theta is root 3, and this 1 plus I root 3 is in the first quadrant, so therefore theta is 60 degree or pi by 3. We know that tan pi by 3 is 60 degree. So once we have r and theta, we can write polar form of 1 plus I root 3. So therefore z equal to 1 plus I root 3, and we know that polar form of complex number z equal to x plus iy is z equal to r into cos theta plus I sin theta. So here we put value of r and theta. R is 2 and theta is pi by 3. So we have 2 times cos pi by 3 plus I sin pi by 3. Now 1 minus I root 3 is nothing but conjugate of 1 plus I root 3. So conjugate of 1 plus I root 3 means conjugate of this 2 into cos pi by 3 plus I sin pi by 3. So this is nothing but conjugate of 2 into conjugate of cos pi by 3 plus I sin pi by 3. Okay, we are using the property of conjugates. If we have two complex numbers in the product, then conjugate of product equal to product of conjugates. Conjugate of z1 into z2 equal to conjugate of z1 into conjugate of z2. Here z1 is 2 and z2 is cos pi by 3 plus I sin pi by 3. Now 2 is real number, so conjugate of 2 is 2 and conjugate of cos pi by 3 plus I sin pi by 3 is cos pi by 3 minus I sin pi by 3. So therefore we have 1 minus I root 3 equal to 2 times cos pi by 3 minus I sin pi by 3. So we have converted 1 plus I root 3 and 1 minus I root 3 in polar form. Now one more thing, in De Moivre's formula, if we consider negative sign here, suppose I have cos theta minus I sin theta, then this I can rewrite as cosine of minus theta, because we know that cosine of minus theta equal to cos theta, and here I consider minus sin theta equal to sine of minus theta to the power n. So now we can use this De Moivre's formula. Instead of theta we have minus theta here, so using De Moivre's formula, this we can rewrite as cosine of minus n theta plus I sin minus n theta. Now again cosine is even function, so cosine of minus n theta equal to cosine of n theta, and because sine is odd function, negative sign will be outside, so we have minus I sin n theta. So instead of positive sign, suppose we have negative sign cos theta minus I sin theta raised to n, then also this is valid. We can multiply n with theta and we can write cos n theta minus I sin theta. So cos theta plus I sin theta raised to n will be equal to cos n theta plus I sin n theta, and cos theta minus I sin theta raised to n will be equal to cos n theta minus I sin n theta. So we have converted 1 plus I root 3 and 1 minus I root 3 into polar form. Now we can simplify this. First we write this expression 1 plus I root 3 raised to 100 plus 1 minus I root 3 raised to 100. So now in the next step we write 1 plus I root 3 to the power 100 plus 1 minus I root 3 to the power 100. Now polar form of 1 plus I root 3 is this one, 2 times cos pi by 3 plus I sin pi by 3, and we are taking 100 power. So 1 plus I root 3 raised to 100 will be equal to 2 raised to 100 into cos pi by 3 plus I sin pi by 3 raised to 100. So that I write directly 2 raised to 100 into cos pi by 3 plus I sin pi by 3 to the power 100. Same thing here, 1 minus I root 3 is this one, 2 into cos pi by 3 minus I sin pi by 3, and we are taking 100 power. So 100 power of this, that will be equal to 2 raised to 100 into 100 power of cos pi by 3 minus I sin pi by 3. So here we write 2 raised to 100 cos pi by 3 minus I sin pi by 3 to the power 100. So now this is going to be 2 raised to 100. Now we can apply De Moivre's formula. Here angle is same, pi by 3. So we use the formula that cos theta plus I sin theta raised to n equal to cos n theta plus I sin n theta. So we multiply this angle pi by 3 by 100. So we have 100 times pi by 3 plus I sin 100 times pi by 3 plus 2 raised to 100. Now as we discuss, if we have negative sign, then also we can write this is equal to cos theta minus I sin theta raised to n equal to cos n theta minus I sin n theta. So if we have negative sign, then also this is valid. We multiply angle theta by n. So here we write cosine of 100 pi by 3 minus I sin 100 pi by 3. Now we can simplify this. We can see that 2 raised to 100 is common, and we have to write remaining things. Here we have cos 100 pi by 3 plus I sin 100 pi by 3, and here if we take 2 raised to 100 common, we have cosine of 100 pi by 3 minus I sin 100 times pi by 3. So you can see this will cancel out, and we have 2 times cosine of 100 pi by 3, 2 raised to 100 into 2 times cosine of 100 pi by 3. Now 2 raised to 100 into 2, that is nothing but 2 raised to 100 plus 1, that is 101, and we can simplify this angle because I have 3 here. I rewrite 100 pi as 99 pi plus pi divided by 3. So this I can rewrite as 2 raised to 101. This I can again rewrite as 99 pi divided by 3, that is 33 pi. 33 into 3 is 99 plus pi by 3. So now this is equal to, this is 2 raised to 101. 2 raised to 101. Now 33 pi plus pi by 3. So 33 pi is odd multiple of pi, so 33 pi will be somewhere on negative. This angle will be on negative x axis, 33 pi, and we are adding pi by 3 into this angle. So we are in third quadrant, and we know that in third quadrant tan is positive, sine and cosine are negative. So cosine of 33 pi plus pi by 3, this is nothing but minus cos pi by 3. Okay, because this angle 33 pi plus pi by 3 is in third quadrant, and value of minus cos pi by 3, we can take negative sign outside, and value of cos pi by 3 is 1 by 2. So this again we can rewrite as 2 raised to 101 minus 1, because we have 1 power here. So that is nothing but minus 2 raised to 100. So value of given expression is nothing but minus 2 raised to 100. Okay, so in this way De Moivre's formula is very helpful in simplifying this type of expressions. What we have to do is, first we have to convert our complex number into polar form, and we will remember this De Moivre's formula, that cos theta plus I sin theta to the power n can be written as cos n theta plus I sin n theta, and if we have negative sign, then also we can multiply this angle, that is cos n theta minus I sin n theta. The only thing we have to understand is angle must be same. Suppose I have this type of situation, cos theta plus I sin 2 theta, then here I cannot apply De Moivre's formula, because here angle is 2 theta and here it is theta. Okay, so angle must be same, and we can apply this formula. If we have negative sign, then also we can apply this formula. Okay, so this is all about today's session. I hope you like it. Thank you very much.